Welcome back, everybody. We are in Unit 5 talking about real-world machine learning, and this is going to be a very valuable video, and it's going to be on choosing an algorithm. So we have our problem now. We think we can solve it with machine learning. How do we decide on a type of algorithm to do that? And this is going to be the video that addresses that, if only in briefly. Hopefully it will give you a way to think about these decisions and what factors to consider when you are making those decisions. So once again, this video is presented by EDU Onyx. Thanks for listening. So we are going to start, and this is really a process that you can follow. There are 4 general factors that you are going to want to consider when you are picking a machine learning algorithm. And this is just generally, this isn't necessarily the first step. And those 4 factors are the size, quality, and nature of the data. Again, what type of data you have is going to be ultimately what decides what machine learning approaches are available for you to use. Another thing you should consider is the available computational time. Does this algorithm have to run in real time? If so, maybe a very deep neural network isn't the best option for you. The urgency of the task. For example, how much time can I spend on training the algorithm versus, do I need something that needs to be deployed tomorrow? And then again, what are we trying to accomplish with the data? Are we trying to do prediction? Are we trying to do inference? Do we want a sequence of actions? These are all going to be the factors that you consider when going into choosing an algorithm. So moving the wrong way. Step 1 of that process is really determining the learning method that you are going to want to use. And we looked at this graphic in the last video actually as well. And it's a very good graphic. So we've got our 3 learning methods, and those are supervised, unsupervised, and reinforcement learning. And the one you pick is going to be based on 1, the type of data you have, and 2, the goal that you are trying to accomplish. If we're doing prediction, we might use classification or regression or anomaly detection depending on whether or not we have labeled and unlabeled or quantitative and qualitative data. Unsupervised learning, also we're going to have dimensionality reduction in unsupervised learning along with clustering. And then we're going to have reinforcement learning, which is looking at autonomy or generating a sequence of actions. So if you're doing like skill acquisition or learning a task, robot navigation, you're going to want to do reinforcement learning. So this is a good graphic to go over. Maybe you know that you want to do targeted marketing, and we look and we find that under the clustering and unsupervised learning. So you know what type of data or learning model that you would have to have and deploy to do targeted marketing. All right, so that's step 1, deciding a learning method. Once you have that picked out, maybe it's pretty obvious that you want to do supervised learning or unsupervised learning, whatever it is. This is where you have to start. Once that's decided, you can move on. All right, so step 2, we want to consider accuracy and training time. And these are going to be really important to consider before actually picking an algorithm, because a lot of the time, getting the most accurate answer possible isn't always necessary. Sometimes an approximation is adequate depending on what you want to use it for. If that's the case, you may be able to cut your processing time dramatically by sticking with more approximate methods. And that's because really training time here varies significantly from algorithm to algorithm. And training time is very closely tied to accuracy. So we have our little scale here. On the far right, we have very high training time but very high accuracy neural networks. And on the far side of that, you have a linear support vector machine, which is essentially one simple computational operation, and then you have your classifier or your regressor, and very low training time but not as good of accuracy. And so all of the algorithms fall somewhere on this scale, and what you're going to have to decide is whether you value accuracy or it's okay if it's approximate and it has to be deployed very quickly. And again, whatever task you're trying to solve is going to have different levels that they require. If we're doing maybe cancer prediction, we're going to want to be pretty accurate as possible. In other tasks, maybe not as important. So that's always important to consider before going in and picking an algorithm. So next, we want to consider the number of parameters. And this we've talked about a little bit in the past. This is the bias variance trade-off. So again, we want to match the model complexity with the complexity of the underlying data. And we want to do that so that we can avoid our overfitting and a poor ability to generalize that comes along with that. So if you look at this graph, which we've looked at before on the far right, you have high model complexity, which is going to come with low bias, so we're not pretending to know a lot about the underlying data. But again, we're going to overfit our training sample and we get a poor prediction error on our test sample. On the other end, we have low model complexity. Maybe we're trying to use a linear algorithm on a non-linear data set. So that's high bias. We're making a lot of assumptions, but very low variance, so we can't handle a lot of different tasks. And again, we're going to have a high error. So we want to find that sweet spot where we're matching the model complexity with the complexity of our data. So the bias variance trade-off, very important to consider when choosing an algorithm. But there's something that's nice and that are out there, and if you're not that familiar with machine learning, these are some resources that you can use to actually choose an algorithm. And algorithm cheat sheets come in both general versions and software specific versions. So for example, our graphic on the right is from Microsoft Machine Learning Library, and so it will direct you to the algorithms that it has available, whereas the one on the left here is more general. So this asks you a series of questions, and you will ultimately end up at one algorithm. So for example, when we start, do we want to do dimensionality reduction? No. Do we have responses? Yes. Sweet, we're into supervised learning. Are we doing numeric? No. Maybe we're classifying as quantitative, so no, we're over into the classification. Speed or accuracy? Let's be very accurate. Okay, so we've got neural networks available to us. If we want something really fast, we have linear support vector machines, logistic regression, something that would be quicker like that. So this is going to help you kind of end up ultimately at an algorithm depending on the things that you value the most. On the other side, so here is the software specific one. This is only going to offer you solutions that are available in the software package. But again, it works in generally the same way. You have the comparison of accuracy versus training time. So if you look down at the bottom right, you have high accuracy but long training times, and that's a 2-class neural network. On the other side, you have fast training but not as accurate, and those are going to be some of your linear models. So training time and accuracy, probably the thing that you want to consider the most, as well as the type of learning method that you are trying to accomplish. So that is a quick and dirty way of choosing an algorithm. There are going to be a lot of different things that go into which algorithm is the best. And so that's actually going to depend on how much time do you have to researching different algorithms for your problem. For example, do you only have time to build and deploy one network, or could you build and deploy 5 networks and then compare them and see which one performs the best? So that's actually what we're going to be talking about in our next video, is how to actually design and analyze a machine learning experiment where we're maybe trying to compare a couple of algorithms or something like that. So keep listening. This is only part of the process. By the end of this unit, you should be able to be comfortable picking algorithms, testing algorithms, and then using them for your specific problem. Thank you for listening.